Welcome to Unit 6, Video 3. Today we're going to look at special right triangles with applications. Your learning targets are that you can apply the properties of special right triangles, and also that you can calculate and apply the angle of elevation and angle of depression. So there's two different special right triangles, 45, 45, 90 triangle and our 30, 60, 90. We're going to look at a 45, 45, 90 triangle first. Okay. So if I have a 45, 45, 90, okay, I know one is 90 and here's 45, so they have to equal 180, so that means this also has to be a 45-degree angle. Okay, and since my two angles here are the same, that means that this side and this side are the same. So if this is a side length of x and this is a side length of x, I can use the Pythagorean theorem to figure out my hypotenuse. Okay, so it says express the length of the hypotenuse in terms of x. So right here, I would have x squared plus x squared equals, let's just call the hypotenuse for now c squared. X squared plus x squared is 2x squared is equal to c squared. And now if I want to solve for c, I would take the square root. Okay, so the square root of 2 is not a perfect square, so I still have square root of 2, but the square root of x squared, the x and the 2 cancel, so I'm left with just x. Okay, it's kind of hard for you to see up there, but the 2 and the square root cancel and you're left with x. So this will be x square root of 2 is equal to c. So my special right triangle, and it's something you're going to need to know, is that if this is a 45, 45, 90 triangle, didn't come out very nicely, then my side lengths are in ratios of x, x square root of 2. Okay, so this is something you're going to want to have memorized. The way we use it then is to find the value of x. Okay, it says, do I need to use these patterns? No, but you will be asked to find exact values, and so if I say exact, that means you can't type it in on your calculator. Okay, so this one, I know it's a 45, 45, 90 triangle, so I'm going to go ahead and label it with what I know from over here. My two sides across from my 45s represent x, and my hypotenuse is x square root of 2. So you always look for the side that has information. Notice how this one has a piece of information. It tells me x is 4. So I take this and plug it in for this x, which is kind of confusing because I have multiple x's going on here. But that means my answer of x is equal to 4 square root of 2. Okay. Let's go ahead and look at another example. Okay, this one, it doesn't tell me it's a 45, 45, but notice if I have two side lengths that are the same, that means it's a 45, 45, 90. So I label everything. Okay, this is x, and this one is x square root of 2. So I always look at the information that was given right here. I use that, so I have 5 square root of 2 is equal to x square root of 2. Okay, some of you clearly can be like, oh my gosh, obviously x is 5. Maybe you can't see that, so we solve for x. The way I would solve for x is divide by square root of 2. So x is equal to 5. So it means this x is 5, which means my final answer is 5. Okay, that is example 2. Now example 3 says find the value of x. Once again, it tells me my two side lengths are the same, which tells me this is a 45, 45, 90 triangle. So I label my sides. This is x, this is x, this is x square root of 2. So I use the sides that were given to me to solve. So I have 12 is equal to x square root of 2. This one isn't as straightforward as the one we just did. I'll need to do a little work to solve for x. So I would divide by square root of 2. So x is equal to 12 over the square root of 2. It's not proper to leave the radical in the denominator, so I rationalize, so multiply by square root of 2. So x is equal to 12 square root of 2 over square root of 2 times square root of 2 is 2. I would then reduce. 12 divided by 2 is 6 square root of 2. Okay, so that's what x is equal to, and if I plug it in for this x, My final answer then is that x is equal to 6 square root of 2. Okay. So that's for our 45, 45, 90 triangle. Now we're going to go ahead and look at our 30, 60, 90 triangle. Okay. The way that this one is that if I look at an isosceles triangle, okay, all the sides are the same. So if I'm labeling this side 2x, and really then this side's 2x, and this side is 2x, okay, I can break it apart, okay, because this was a 60 degrees. These were all 60-degree angles. If I break it in half, I have a 90, this is a 60, and then 60 divided by 2 will give me a 30-degree angle, okay. This one's kind of hard to see. Let's rewrite that as 60 degrees. All right, so the other thing is I took my side length of 2x and cut it in half. Well, that means that from here to here is really a distance of x, and from here to here is a distance of x. Okay, so rewriting what I have over here, I would have that across from my 30 is a side length of x, and my hypotenuse is 2x. We're going to do what we did before to find a value for here. So for right now, I'm just going to call it b. So I would have x squared plus b squared equals 2x squared. So I have x squared plus b squared is equal to 2 squared is 4 x squared. I'm trying to solve for b, so I will subtract x squared from both sides. So I have b squared is equal to 4x squared minus x squared is 3x squared. And then to solve for b, I take the square root. So b is equal to the square root of 3x squared. Okay. The square root of 3 is not a perfect square, so I still have the square root of 3. But we went over square root of x squared. That square root and the square cancel, and I'm left with just x, so I write that on in front. So that means that this side length here is really x square root of 3. Okay. So for my 30, 60, 90 triangle, I have a side length of x, which is always across from my 30-degree angle. I have a side length of 2x, which is always my hypotenuse, and x square root of 3 is my 60-degree angle. Okay. One thing I would point out is because some people struggle with remembering the different square roots. I have my 45, 45, 90. This one's x square root of 2. Notice this one has a square root of 2 and this one has a square root of 3. Okay, how many different angles or different side lengths are there? There's only 2 different, right? There's a 45 and a 90, or there's an x and an x squared root of 2. So that's why there's 2. Here on my triangle, all 3 sides are different, so it's a square root of 3. So if you're struggling with remembering which one has square root of 2, which one has square root of 3, that's one way to remember it. So let's go ahead and look at some examples. So 30, 60, 90 triangle. Find the values of x and y. So this time I have a 60 and a 90. That makes this a 30. So let's go ahead and label everything. Across from my 30 is always x. Across from my hypotenuse is always 2x. And across from my 90 is always x square root of 3. So I go ahead, use the side that I was given. I have 2x is equal to 10. Divide by 2. So x is equal to 5. If I substitute that in for this number, it tells me that x is equal to 5 for my answer here. And y, I plug in 5 here, so y is equal to 5 square root of 3. And I am done. And just to point out, these are the exact answers. You'll be asked to give exact answers on your quiz. Okay, if you put them in your calculator and round, that's not an exact and you will lose points. Let's go ahead and look at B. Okay, once again, it shows me this time it's a 30, 60, 90, so I start labeling. Across from my hypotenuse is always 2x, across from my 30 is always x, and across from my 60 is x square root of 3. Okay, I look. No information given on these two sides, so I have to use this one. So x square root of 3 is equal to 12. I solve for x. Take the square root of 3 on both sides. So I have x is equal to 12 over the square root of 3. We need to rationalize, so I multiply by square root of 3. Square root of 3. So I have x is equal to 12 square root of 3 over square root of 3 times square root of 3 is 3. Lastly, 12 divided by 3, 4 square root of 3. Okay, so that's my answer for x. Okay, so I plug it into here. So this one is really just 4 square root of 3. So x equals 4 square root of 3. That is one answer. Now we need to solve for y. It's 2 times our x. Taking this and plugging it in for here, I have y is equal to 2 times 4 square root of 3. So all I need to do is 2 times 4 is 8, so y is equal to 8 square root of 3. Okay, and that is my final answer for 4B. Some other problems that you can do with special right triangles is find other exact values. Okay, exact once again means you do not round. There is no decimals. Typically it involves a square root sign. So it tells me to find the exact value of sine of 45. Okay, well I know this one is a 45, 45, 90 triangle. If this is x, that means this is my 30, 60, 90. So if I want to find sine of 45, that means I'm looking at this triangle over here. Sine, we have our SOHCAHTOA. Sine is opposite over hypotenuse. So if I'm looking at my 45, my opposite is x. My hypotenuse is x square root of 2. So sine of 45 equals my opposite, x, over my hypotenuse, x square root of 2. I simplify. Those x's cancel, so I really have 1 over square root of 2. Then I have to rationalize the denominator, so I multiply by square root of 2. So I get square root of 2 over square root of 2 times square root of 2 is 2. So my exact answer is square root of 2 over 2 for sine. Okay. Now we're going to go ahead and find the exact value for tangent. Tangent of 45, so that means I'm looking at my 45-degree angle. Tangent's opposite over adjacent. Okay, so tangent 45. Looking at this 45-degree angle, it doesn't matter which 45-degree angle I look at, I'm going to get the same answer. Tangent is opposite, so x over my adjacent x. So I have x over x, which is equal to 1. So my tangent of 45 equals 1. Now it says find the value of sine of 60 degrees. So that means I'm looking at this angle. Okay, and if I'm doing sine, it's opposite over hypotenuse, so sine of 60. My opposite is x square root of 3 over my hypotenuse, 2x. Here I notice my x's will cancel, and so I'm left with square root of 3 over 2. So sine of 60 is square root of 3 over 2. Now I only have one more to do. I need to find tangent of 30 degrees. So now I'm looking at this angle. Tangent's opposite over adjacent. My opposite is x over my adjacent, which is x square root of 3. I notice my x's cancel, so I have 1 over square root of 3. It is not proper to leave that square root in the denominator, so I multiply by square root of 3 over square root of 3. So I get tangent of 30 degrees is equal to 1 times square root of 3 is square root of 3 over square root of 3 times square root of 3, 3. So square root of 3 over 3 is my tangent of 30. Okay. So those are our special right triangles. The second part of today's notes is talking about the angle of elevation and angle of depression. So if you need to take a break, now would be a good time. Otherwise, I'm going to move on and finish up the note sheets. So angle of elevation, okay, what it means is that you are on the ground or you are looking up. Okay, so it's an object as seen by an observer is the angle between the horizontal line from the object to the observer's line. Okay, so essentially, if I am on the ground and I look up at an object, my angle of elevation is the angle down here. So if you're looking up, angle of elevation. If you are looking down, it is angle of depression. So say I'm up on a building, okay, and I am looking straight out, and then I look down. This angle here is my angle of depression. The thing about angle of depression you need to take into consideration is that it's not in my right triangle. If I'm looking at this as my right triangle, okay, I might feel like that does not help me, but it does because this angle and this angle are alternate interior angles, so they are the same. It's a little geometry for you. So So if you know your angle of depression, you also know that this angle in your triangle, they are the same value, same angle. Okay, so let's look at some problems that have angle of depression and elevation. So a tree casts a shadow 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64. Find the height of the tree. I always say draw a picture. So I'm talking about a tree. We could actually draw a tree if we wanted to, but. Okay, so I have my tree. The shadow of my tree is 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree, so essentially I have this right triangle here, is 64 degrees. We need to figure out the height of my triangle. Okay, so I have my picture drawn here, and I know that if I have this angle, this is my opposite, and this is my adjacent. So I'm going back to SOHCAHTOA, who uses opposite and adjacent. Tangent. So I have tangent of my angle, 64 degrees, is equal to my opposite h over 25. To solve this one, I would just multiply by 25 on both sides. So h equals 25 times tangent 64. Type it in your calculator and you get 51.258, and this is labeled in feet. So the height of the tree is 51.258 feet. Okay. Example 10. When landing, a jet will average a 3-degree angle of descent. What is the altitude to the nearest foot of a jet on final descent as it passes over an airport beacon 6 miles from the runway? Okay, so here's the beacon. So we are saying it's right above right now. Okay, and our airport is 6 miles away. This is where we're landing. Okay, so here's my triangle. So my plane is flying this way, and they're telling me that the angle of descent is 3 degrees. Okay, well, if this is 3 degrees, because of my alternate interior, I also know that this one is 3 degrees. And we are trying to find the altitude. So remember, altitude is the height here. So this is my altitude. So I'm going to call that A for altitude. Now I go ahead and look. I'm looking at this angle. This is my opposite. This is my adjacent. So we're using the same trig function we just did. So it's tangent of 3 degrees is equal to A over 6. But we need to be careful because notice how this says foot and this says miles. Okay? So there's one way you can do it. You can solve it and then make it into feet, or we can put 6 into feet right now. Maybe let's do that. So we need to remember that 1 mile equals 5,280 feet. Okay, so if we do that, we have currently 6 miles. And I know 1 mile is 5,280 feet. So these cancel. So I would take 6 times 5,280, and that means that this is 31,680 feet. So I really don't want to solve this problem because I want my answer in feet. I want tangent of 3 degrees to equal A over my feet. And then to solve for A, I would multiply by that 31,680. So we would take tangent of 3 times 31,680. And when you do that, you'll get that your altitude is 1660.278 feet. However, it says to the nearest foot. So this 2 tells me to stay the same. So they are 1,660 feet in the air. That is their altitude. That would be your answer for that one. Okay, so be careful about things like feet and miles so you change them to be the proper thing. Last example, suppose a tree 50 feet in height casts a shadow of length 60 feet. So once again, we got a tree. This time, the height is 50 feet. and it casts a shadow. Ooh, it's not a very good triangle, but of 60 feet. What is the angle of elevation from the edge of the shadow to the top of the tree? So I'm at here looking up. So this angle we need to find. So if I'm trying to find this angle, I have my opposite. I have my adjacent. So it's tangent of x is equal to 50 over 60. Remember, whenever you are trying to find that angle, you do the inverse. So it's tangent inverse of 50 over 60. And when you type that in, you would get 39.806 degrees. That is the angle of elevation for that tree. Okay. That will do it for Unit 6, Video 3. If you have any questions, please come and ask. Otherwise, have a great day, and I'll talk to you later.